With paper 1 out the way, it's time to turn our attention to paper 2. So today's video covers my top 4 tips for GCSE Maths paper 2 revision. Tip 1, my paper 2 revision checklist. Using the link in the description, go to my website and download my paper 2 revision checklist to identify the topics that you need to prioritise. Then work through those specific video lessons available for free on my YouTube channel. Tip 2, my paper 2 practice booklets. Once you've worked through the YouTube lessons identified by the revision checklist, then you need to work through my paper 2 specific practice booklet to solidify your understanding of the topics in preparation for the exam. Tip 3, my paper 2 practice papers. The night before the exam, it's time to complete my paper 2 practice paper to refresh your understanding of the topics that I'm guesstimating will appear on paper 2. Tip 4, my rapid revision system. Alternatively, if paper 1 didn't go as well as you were hoping, or you just need a time-efficient solution due to the other subjects that you need to revise for, then you should sign up for my rapid revision program upgrade, as it combines all the benefits of the previous points but turns them into a personalised revision plan for paper 2, which means that all you need to do is complete my paper 2 revision quiz and you'll know exactly which lessons or topics you need to work on to maximise your maths in minimum time. This is my paid programme, but if you sign up for 1 month now, then you'll get priority access to both my paper 2 and 3 specific revision resources. Sign up for a free trial of Upgrade today. Okay, welcome to this video where we'll be having a look at a practice paper for the 2025 GCSE Maths Paper 2 Higher Tier. Now, as always, there will be a QR code on the front of this booklet so that you can get back to this video at any point. So we're going to get started with question 1, and question 1 is using a calculator. So for this question, you just need to replicate exactly what's on the paper with what's on your calculator. So pressing that fraction button first, and just making sure that you know where all those buttons are. And once you've typed it all in, just double check, look back at your calculator, just make sure it looks exactly the same as how it does on the paper. You might be surprised at how many times you sometimes accidentally press an incorrect button. So for this one here, my answer comes out as 1.765279223. So as long as you're getting the same answer there, that should be absolutely fine. If not, just double check, have a look at how it looks different on the page to on your calculator screen. Now part B here asks us to write the reciprocal of 0.625. Now a reciprocal, when looking at a fraction, is when you flip it over. Now any number or decimal could be written over 1. So when we write the reciprocal of this, it becomes 1 over 0.625. Now we can just type that into the calculator, 0.625 on the bottom, and that comes out as either 8 over 5 or 1.6. So either of those would be fine, but there is the reciprocal of 0.625. On to our next one, we are looking at mean from a table. So here we are finding an estimate for the mean. We find an estimate because we are going to have to use the midpoints of the height, as we don't know the exact heights of these children. So if we first write down the midpoints, 135, 145, 155, 65 and 75, and we want to multiply across each row to find the estimated total for each of these rows. So we could do this on the calculator, so 135 times 4, which is 540, 145 multiplied by 11, and as always, just be really careful. I know you're typing in lots of multiplications, but just make sure that you're very careful that you do type them in correctly. We don't want to get a number wrong along the way. 165 times 22 is 3,630, and 175 times 19 is 3,325. So from here, we want to go and add all of these together to get our overall estimated total. And once we've added them all together, we'll write that down. The total there is 12,810. Now it tells us here that there are 80 children. If not, we'll get it from the bottom of this total frequency. And to find the mean, we take the overall estimated total, divide by how many children there are, which in this case is 80, we get an answer that comes out as 160.125. And as always, make sure your answer makes sense. This one does. 160 is just at the start of that fourth category there. Just above that, you have the 150 to 160, which is also the modal class interval there, the most common interval. So just after that makes a lot of sense for our answer, and it's within the ranges given to us in the question. Part B here asks us to draw a frequency polygon. Now, frequency polygons, we're going to plot on the midpoint, which fits in very nicely with what we've already done above. And we're just going to plot those frequencies. So it goes 135, 145. So just double check, make sure that you are very happy with where those midpoints are. And then, of course, we can just go ahead and plot all of those numbers. So there's all my midpoints slightly marked out. And it goes 4, 11, 24. So, of course, check your scale. Put 4, 11, 24's just there. There we go. And then we have 22 and 19. So 22 and then 19 just there. Now with a frequency polygon, we join them up with straight lines, dot to dot, just from the left, going to the right, joining them up, and then just stop there. Don't join them together, anything like that. We just have to join the very first one to the very last one, dot to dot, with nice straight lines. And there we go. There is a frequency polygon. Question 3, we're looking at a Venn diagram. Now it says the only numbers we're allowed to use here are from 1 to 10. A is the even numbers, B is the factors of 10, but only from that list that's given to us. So the even numbers in that list, we have 2, 4, 6, 8 and 10. And the factors of 10, we've got 1, 2, 5 and 10. Now you can see here we have a 2 and a 10, which is in both, so that goes into our intersection. We're going to cross those off from the main list. We then have in B a 1 and a 5, again crossing those off from our main list. And then in A there is a 4 and there is a 6. And we'll cross those off again from our main list, 4 and 6. Double check that they're all in. We have 2, 4, 6. We don't have the 8, so there we go. We've identified we're missing the 8. And there we go, 8 off the main list as well. I've already crossed off, so maybe I meant to write that in. And then we just need to have a look at what numbers are left over. So there is a 3 that is not in either of those. There is a 6 that we should have crossed off, a 7 and a 9. So just double count these. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers in the Venn diagram. None of them are doubled up. We only have one number in each position. So there we go, our Venn diagram is completed. Lots of different questions you could be asked in regards to the set theory behind this. This particular one is saying a number is chosen, find the probability the number is in set A, and then we have the intersection with B. So the numbers that are in the intersection, we have 2 and 10. So there are 2 numbers in the intersection and there are 10 numbers in total. So our probability would be 2 out of 10. Now, of course, not forgetting, you could have the U, which is the union, and that would be all the numbers in the circle. So 4, 6, 8, 2, 10, 1 and 5 would be in the union. And you can also have the dash with the letters as well, something like B dash, which means not in B, which would just be the 4, 6, 8, 3, 7 and 9. So it can't be in the intersection if it's not allowed to be in one of the circles. So lots of different little bits you could be asked there in regards to set theory, but this was looking at the intersection, which is 2 out of 10. Question 4 here is looking at some speed, distance and time. Now this particular question is about 2 journeys that are almost getting sort of blended together. Now when I have 2 journeys like this, I always draw a two-way table. I'll have my speed, my distance and my time. And I need some rows or columns to indicate these different parts of the journey. So we have Oxford to Bristol as one journey, and we have Bristol to Bath as another journey, and we have our overall journey. So for this one here, we are given some distances in those first lines. We have 56 kilometres and 61 kilometres, and we have an average speed from Oxford to Bristol, which was 70, and we have a time from Bristol to Bath of 75 minutes. It says to work out the average speed for the overall journey from Oxford to Bath. And the overall speed is just up here. So with questions like this, to get the overall speed, we have to use our speed is equal to distance over time formula, which you can write as a formula triangle if you like. Speed, distance, time. And to get speed, it's always distance divided by time. We can't add together speeds, unless of course the distances were exactly the same, and here they're not, so we are going to have to work out the overall distance and the overall time. So what we can work out to start with, there is a box down here just missing for the time. So if we cover up time in our formula, it's distance divided by speed. So that's 56 divided by 70, which comes out as 0.8. Now, 0.8 is in hours, but our next speed is given to us in minutes. So we're going to want to convert this into hours as we're working in kilometres per hour. So 75 out of 60 minutes, and we can type that in on the calculator. 75 out of 60 gives us 1.25. Now you could work out the speed from Bristol to Bath, but we don't actually need it in this question because we can't add it to the other speed. We can add these distances together and we can add these times together. And once we've got the total distance and the total time, we can work out the overall speed anyway. So I'm not going to waste any time working out the speed for that middle journey in this question. 56 plus 61 is 117, and 0.8 plus 1.25 is 2.05. So I can now work out that overall speed. I can do the overall distance, 117, and divide it by the overall time, 2.05. And if we type that in on the calculator, we get an answer, which is a long decimal here. It's 57.07317. Some recurring dots above some of these, but the question did give us a big hint here that it was going to be correct to one decimal place. So we'll chop that after the 0, and our final answer will be 57.1. The speed in this question was in kilometres per hour, so kilometres per hour, which of course, if it's on the dotted line already, we don't need to write, but our overall speed there is 57.1. It is on the dotted line, so 57.1 as our final answer. Okay, so our next question is looking at some area and density here in terms of the space that a cow has in a field. So it says there are 48 cows in field X, the area of field X is 192, and there are 120 cows in field Y, and the area of field Y is a rectangle measuring 15 by 18. The area per cow in field Y is less than the area per cow in field X. How much less? Now, field Y doesn't give us the area, so we will need to work this out. 15 times 18 will give us the area of that rectangular field. So 15 times 18 gives us an overall area of 270 metres squared. From here, we just need to compare how much space each cow has. So I'll do field X and field Y. Now in field X, we have 192 divided by the 48 cows. 192 divided by 48 gives us the answer 4 metre squared. In field Y, we have 270 metres squared, and that's divided by 120 cows. So 270 divided by 120, and that gives us 2.25 metres squared. So there is clearly a difference between these. So if we do 4, subtract 2.25, that gives us my difference, or how much less it is. So 4 minus the answer, and that comes out as 1.75 metres squared. And there we go, there is the difference between the two fields. So that's some population density there, just looking at the space that particularly in this question is more about the cows, but also could be applied to a human-based question as well. So here we go, 1.75 is our final answer. Now part B here is looking at some area volume units. This one here, particularly looking at volume units where we have centimetre cubed involved, it says Amir says 40 centimetre cubed is the same as 400 millimetre cubed. Because there are 10 millimetres in a centimetre, that is correct there, 10 millimetres is the same as 1 centimetre, so, but he says so you multiply by 10. Amir's method is wrong, explain why. So you could come up with your own language for this, but to get from centimetres to millimetres in terms of changing the number, yes, absolutely right, we do times by 10. But when it comes to centimetres cubed to millimetres cubed, the 10 is actually 10 cubed. 10 cubed is 1,000, so whichever way you want to write this, you have to actually multiply by 10 cubed, or you have to actually multiply by 1,000, anything along those lines there, and not forgetting that when the units are squared, so centimetre squared to millimetre squared, then the actual conversion is just 10 squared. It's quite nice really, but it is something that people tend to forget. So there we go, you could come up with your own words for that, but we are saying something along the lines of, actually, he should be multiplying by 1,000. Okay, so question 6, we have some expressions as side lengths and we have a compound shape involved. So it says the perimeter of this shape is 86 centimetres, work out the area of the shape. Now we're given some of the side lengths, and with any compound shape like this where we're missing sides, we want to have a look individually at the sides. So the vertical side here is 23 and over here it's 14. So to get this vertical line here, we would do 23 subtract 14, which gives us a height of that part, which is 9. We can take the same approach for these horizontal lines. We have 6x and it has to hit a total of 8x down here. So this little part here is 2x. Now we can create an expression for the perimeter, which is adding together all the pieces around the outside. Now if we add up the x's to start with, we have 8x, 6x and 2x, which in total is 16x. And if we add up the numbers, we have 23, 9 and 14, or 23 times 2, which is 46. So that right there is an expression for the perimeter. But it does tell us the perimeter is equal to 86, and therefore this expression is equal to 86. So from there, we can actually solve this equation and find out the value of x. So if we take away 46 from both sides, we get 16x is equal to 40. I can now solve that equation, dividing by 16, and we get x is equal to 2.5. Now I know the value of x, I can substitute that back into the side lengths, and this particular one, or this particular question, actually asked me to then work out the area of the shape. So if I substitute it back in, 2x would be equal to 5, 8x would be equal to 20, and 6x up here would be equal to 15. Up to you now how you decide to split this shape up. I'm going to split it going down here. So I've got my two rectangles. For this one on the right, I have 5 multiplied by 14, and 5 times 14 is equal to 70. And on the left here, we have 23 times the 15 at the top. 23 times 15 is equal to 345. So the overall area for this question, I would do 345 add 70. And if we add those together, we get 415. And that is meters, is it? Or was it centimetres? It was centimetres, so centimetres squared. Always check back at the question. We spotted the centimetres here, so it is in centimetres squared. So there we go, that's the overall area. Now, of course, remember with questions like this, with forming and solving equations, there are a ton of different types of questions. There are so many different shapes. They can be within the angles. So practicing forming and solving equations is obviously very key, as there are so many different types of questions. But that was a really nice one. We have 415 centimetres squared. Okay, on to our next question, and we are looking at a reverse percentage. So this says Lena's annual salary increases by 6%. After the increase, her annual salary is £42,696.80. Work out Lena's annual salary before the increase. Now there are two ways of approaching this. I like to just take a nice reverse percentage approach. As this has gone up by 6%, it's now 106%, which is equal to £42,696.80. I can go down to 1% and then up to 100%. Very nice and quick to do. I just divide by 106 and then times by 100. So when we do that, 42,696.80 divided by 106 is £402.80, and then times that by 100 and we get her old salary, which is £40,280. Now you can use a multiplier method here. If you use multiplier methods when increasing percentages, then we would have timesed her old salary by 1.06. So what I could do is just divide her old salary by 1.06 and you get your answer straight away. Completely up to you though, whichever you prefer. If you're more comfortable using multipliers, then stick to using multipliers. But there we go, there is our reverse percentage. Okay, so question 8 says Emily invests X pounds in better investments for 3 years. Zane invests X pounds in Country Bank for 3 years. So straight away, because it says X for both of these, it means that they invest the same amount of money. We then have the two separate banks, and it says at the end of the 3 years, the value of Emily's investment is £344,605. Work out the value of Zane's investment at the end of 3 years. Well, in order to work out Zane's investment, we need to know how much money he invested. So this is a reverse compound interest question where we are going to have to look at Emily's investment and figure out how we go back to the start. Now, she invested for 3 years, so whatever that amount of money is, and let's label this Emily, she started with X amount of money. That would have been multiplied by, for 2.5%, 1.025. If you're not sure on that, add the 2% to 100, it's 102.5%. You can either press your percentage button on the calculator, or you can divide that by 100 and you get your multiplier, which is 1.025. So we'd have times by 1.025 to the power of 3, as it's 3 years, and we get the answer 344,605. So to work out the value of X here, we would divide by 1.025 to the power of 3. That'll tell us the value of X. So X will be equal to, we'll type it in on the calculator, 344,605 divided by 1.025 cubed. And that gives us 320,000. Now that means Zane actually invested 320,000 into this county bank. So in this bank, you get 2% interest for the first 2 years and then 3.5% per annum for each extra year. So we want to know the multipliers again. So for 2%, we'd use 1.02, and for 3.5%, we'd use 1.035. And again, you can use the method that we spoke about on the left to get those multipliers. So in this bank, you get 2% for the first 2 years. So we do 320,000 times by 1.02, which will get us our 2%. That's for 2 years, so squared. You can either work that out and then times it by 1.035, or we can do it all in the same step and just times by 1.035. That's going to do it all for us. Just be very, very careful. Make sure that you put that power in. So 1.02 squared times 1.035. And that gets us my final answer, which is 34 or £344,580.48. Now that has actually also come to the nearest penny, so we didn't have to round that, but our final answer, or the final value of Zane's investment, is £344,580.48. So there we go, that was using compound interest. We had a slight reverse compound interest there to start with, to find the starting amount of money, and then we ran that through the other bank, which had two different percentages that we had to use there. 2% for the first 2 years, and then 3.5%. And there we go, there was some compound interest. Okay, so question 9 is looking at a cumulative frequency graph. It says here the cumulative frequency graph shows information about the times taken for 60 students to complete a puzzle. And we can see it lands up at 60 at the top here, and it now asks us for these 60 students, the least time was 24 seconds, the greatest time was 96. On the grid, draw a box plot for the distribution of the times taken. Now with a box plot, we can plot the smallest and the highest value here. So 24 and the 96, we can actually plot those. We want to read this scale carefully. Each square goes up in twos, as there's 5 squares between 20 and 30. So 24 would be just here, and 96 is going to be 2 squares before the 100, so just there. But we need to find the median and the lower and upper quartile. So we'll get that from the cumulative frequency graph. Now it's out of 60, so our median will be at 30, and then our lower quartile will be halfway between 0 and 30, which is going to be here at 15, so that'll be our lower quartile. And the upper quartile will be halfway between 30 and 60. So that's at 45. You can add those two together, 60 and 30, and divide it by 2 if you're not sure how to find the midpoint there. But 45 is our upper quartile. So from here, we need to go across from these values, and then we're going to go down and read those values very, very carefully. I'm going to start just going across on all of them until I hit my cumulative frequency curve. There we go. And I can go down, and we'll read these all in a moment. Just going to mark them all out to start with. And there we go. Hope I can get a nice straight line here. There we go. So my lines have gone ever so slightly off. So we're looking at this number here, and just after the 40 there. So my lower quartile, and again, making sure that we read the scale carefully, each one goes up in twos. So that's going to be 42 for my lower quartile. My median is at 54, and my upper quartile is at 64 there. My line has gone ever so slightly to the left, but we've got 64 for that one. So we can now draw this box plot. We have 42, so that would go just here. We have 54, so 50 is just here. 2 squares after that, so 54. And then we also have 60 and 2 squares after that, so 64. There we go, we can join these up. That makes my box, and then we have these long parts on the outside. And there we go, there is my box plot. So that was also finding the median, lower quartile and upper quartile from a cumulative frequency curve or a cumulative frequency graph, and then using that to draw a box plot, not forgetting those key numbers in there with the median and the lower and upper quartile. Okay, there we go. So our next question is looking at a frustum and looking at a sphere. Now it says here the volume of a sphere and the volume of a cone, and it says the diagram shows a frustum, which is a cone with part of it cut off the top, which we can see, which is made by removing a cone with a height of 3.2 from a solid cone with a height of 6.4 and a base diameter of 7.2. The frustum is joined to a solid hemisphere of diameter 7.2 to form solid S, which is shown below. Calculate the volume of solid S. Now it's up to you which bit you start with here, but the hemisphere that's on the bottom is actually quite easy for us to work out because we have the formula just here for a volume of a sphere. It doesn't matter which one you start with here, but that hemisphere is definitely a nice one to work out. Just remember, if it's a hemisphere, then it's going to be half of that. So it's half times 4/3 pi r cubed. You could times those fractions, it becomes 2/3. When you simplify the fractions there, we get 2/3 pi r cubed. I'm just going to leave it as times half. So we can work out the hemisphere straight away. So 1/2 times 4/3 times pi times the radius cubed. Now the radius is half of that diameter, so 7.2 divided by 2 is 3.6. So 3.6 cubed. I do like to label next to it that I've worked the diameter out, so r is 3.6. And we can type that straight into our calculator. So 1/2 times 4/3 times pi times 3.6 cubed. There we go, that gets me the volume of the hemisphere. So 97.7160979, and that is the hemisphere. Now obviously there's a lot of working out to do here, so we want to label this so we know exactly what we've just worked out. So there's my working out, really nice and clear that I've done that for the hemisphere. I'm now going to move back to that frustum. Now with a frustum, we need to have a look at what proportion has actually been removed. This is a relatively nice one because the proportion here, it's half and half in terms of the height. So in terms of the size of the cone that's been removed, it's half of that, or one is double the size of the other. So it's quite nice because it allows us to easily get the diameter down here, which obviously stretches across the top of this smaller cone, as that's going to be half of 7.2. So that diameter there is 3.6, which means the radius of the big cone is 3.6, and the radius of this small cone is going to be half of 3.6, which we can always do on the calculator, but we get 1.8. So in order to get the volume of this frustum, which is connected to our hemisphere, I'm going to need to work out the volume of the large cone before anything was removed, so a radius of 3.6. I'm going to need to work out the volume of the small cone with a radius of 1.8, take those away from each other, and I'll have the volume of the frustum. Once I've done that, I can add it to the hemisphere. So if we label this down here, let's just call it the big cone as the first thing that we're going to work out. The formula is 1/3 pi r squared h. So for that big cone, it's 1/3 times pi times the radius, which was 3.6 squared. And that large cone had a height, and it says it in the question anyway, a height of 6.4. So times 6.4. Now we can type all that in a little bit. Let's also do the small cone. Get the working out written down. The small cone, similar formula, 1/3 times pi. Half the radius was 1.8. And then the height of that, the smaller cone, was just the 3.2 just here. So we have the height of 3.2 for that particular cone. So that'll be our height down the bottom, 3.2. And now we can work both of these out. So 1/3 times pi times 3.6 squared times 6.4. That gives me a volume of 86.85875,369. And for the next one, we have the radius 1.8 and the height of 3.2, and that gives us a volume of 10.85734421. Now I've got some quite long numbers here, so we do need to work out the volume of the frustum now. So we need to take them away. So the frustum's up there. We're going to subtract both of these. I'm going to label this as the frustum. And when we take these away, so we have 86.85875369 minus that previous answer, and the frustum is equal to 76.00140948. So we have our two volumes. We have the volume of the hemisphere and we have the volume of the frustum. We want to add those together so we can have the total volume of S, which is what they called the shape. So we need to add the 97.71600979, and that gives me my overall volume, which is 173.717507.4. There we go, this is a volume. Check the units, it was in centimetres, so that would be in centimetres cubed, which is given to us on the dotted line there. However, this question doesn't tell us how to round our answer. Now, when a question doesn't tell you how to round the answer, then the best answer you can give is the full answer that's on your calculator screen. So it seems like a very, very strange answer. More often than not, you are going to be asked to give your answer to a certain amount of decimal places, but the best answer, if you're not asked how to round it, is to give that full answer there. If we did round it, it wouldn't be unreasonable to write 173.72 here, centimetre cubed, as beyond that it does start to get a little meaningless in terms of the volume, but the best answer you can give there is the fully unrounded version, unless you are asked to round your answer to a certain amount of decimal places. Okay, there we go. So there is the volume of S, and that was looking at cones and spheres, and in this case also a frustum. Okay, so looking at some subject of a formula. So here we have a fraction involved. We're trying to make m the subject, so we need this to first be a nice straight line formula, and then we want to get all the m's on the same side. Now I like to remember to put this into a bracket because we're going to times by the m minus 1, and that's going to move it over to the left, but it does create this single bracket that we do need to expand, which you can expand as you move it, but just be very, very careful because both of those pieces there get times by the f, so it's minus f here. So that now equals 3m plus 4. Now at this point it's always a little annoying because there are two ways now of rearranging this. We can either move the m's to the left, or we can move the m's to the right. Now I tend to just look at the formula, and for me personally, because I've done a lot of these, I'm going to move this minus f to the other side so that it creates as many positive pieces as possible. You can move it either way, so there are two variations to this, but I'm going to move that to the right. I'll put plus f here, which creates 3m plus 4 plus f. I'm now going to minus the 3m so that they're on the same side, and we have fm minus 3m is equal to 4 plus f, or f plus 4. Either way, depends on how you want to write it, completely up to you. Now that I have the m's on the same side, and there's two of them, I have to factorise, and I can factorise m out of the bracket, which leaves me with f minus 3. Now visually, we do only have the 1m, so we can make m the subject, and the final step is just to take this bracket that we've created and divide by the bracket f minus 3, and we get m is equal to f plus 4 over f minus 3. Now there are different ways, of course. You could have moved the m's to the right hand side. The formula will look very similar, but you'll have some different symbols involved. So just bear that in mind, but this can be done one of two ways, and we're going to write that on the final line there. So m equals f plus 4 over, and it was f minus 3. And there we go, f plus 4 over f minus 3. But again, remembering there are two answers that you can give there, both are fine. Okay, on to a quadratic sequence. So it says here are the first 6 terms of a quadratic sequence. Find an expression in terms of n for the nth term of the sequence. So the first thing to do, and always the first thing to do, is to find the second difference of the sequence. Now we don't necessarily actually need all of the terms. This would be plenty. We only need a few. In fact, we only really need about 3, but let's have a look. So we have 3 differences here. So 4, 10, 16, which means the second difference is 6. Now there are 2 different ways of approaching these questions. Either we divide this second difference by 2, which we're going to have to do anyway. That tells us how many lots of n squared this is related to. And then we create that sequence and find the difference. Or there are some formulas that you can use. Now the formula we have is 2 lots of a is equal to this bottom number. 3 lots of a plus b is equal to this middle number. And a plus b plus c is equal to this top number. And all we have to do is solve these little equations, and all quadratic sequences are written in the form an squared plus bn plus c. Any of those values can also be equal to 0, which just means that little piece will disappear. But let's solve these and figure out what we've got. So we have 2a is equal to 6, divide by 2, a is equal to 3. So we can start our quadratic nth term off, because a is 3, so we know it's 3n squared. We can then move to the formula above. 3a plus b is equal to 4. So 3a plus b is equal to 4. We now know that a is 3, so 3a becomes 9. So we have 9 plus b is equal to 4. And if we subtract 9 from both sides, we get b is equal to, and just little steps like this, don't forget we are using a calculator, so we can just type in 4 minus 9, but that comes out as minus 5. So that's minus 5n. And now we want to find c, so a plus b plus c equals 6 on that top row. So we have 3, add negative 5, which is minus 5, plus c equals 6. 3 minus 5 is negative 2, so we have negative 2 plus c is equal to 6, and therefore c is equal to 8, so plus 8. So there we go, you've got lots of little equations to solve, but depending on which method you prefer, this method here does require a little bit less thought process than your other method, which is writing out the actual 3n squared sequence and comparing the difference, and then creating a linear sequence off the back of this, which would take quite a bit of time. So this formula method is very, very nice, particularly if you are good at remembering formulas. If learning some extra formulas is potentially not for you, then you can check the video in the description, which goes through the explanation of how these sequences are actually created. But there we go, there is a quadratic sequence for you. Now this next question is looking at bounds. Now this particular bound has a fraction involved, so we have to think about what to do with fractions when we have bounds, and it has a subtraction involved on the numerator there, so we're going to have to be super careful. Now no matter what we do, we want to write the error intervals for these numbers. So x is 12.76 between 4 to 3 significant figures. So I always do the upper bound first, 12.76, and then stick the 5 on the end. And then the lower one I always find easier to see because it's 765 at the end, it'd be 755. So 755. I'm going to do the same for all three of these. So y is between, and we have 4.895. So if that's 895, we have 885. So 4.885. And then for our final error interval, we have 2.4. This is z. So 2.45 and 2.35. Now we just need to think logically. This question wants me to get the lower bound, which means it wants me to create the smallest possible answer. Now to get the smallest possible answer with a fraction, we want the smallest number on the top and we want to divide by the biggest possible number. Now that means on your denominator here, we want the biggest possible z, which is going to be the 2.45. So we definitely want 2.45 on the bottom. I now just need to think about how I create the smallest possible number on the numerator. So if we have a subtraction involved, to create the smallest possible number, I would want to have the smallest x take away the biggest y. And you might default automatically and just think, well, I'll just put the two smallest numbers on the top. But think about it with some different numbers. If I do 10 take away 2 and 10 take away 3, well, 10 take away 2 gives me 8. 10 take away 3 with a large number that I'm subtracting gives me 7. Obviously, they're just numbers that I've completely made up there, but we want to get the smallest x, so 12.755, and subtract the biggest y. That's going to give me the smallest number on the numerator. So take away 4.895. Once we've done this, double check your thought process. Just make sure you're happy with all the types of numbers you've created. Does that definitely create the smallest possible answer? If you're not sure, you can always test some slightly different combinations. So you could do this, then you could swap the 4.895 to 4.885 and see if it makes a smaller answer. Or you could swap the 12.755 for the 12.765. Okay, you will notice that you will get the smallest answer though with this combination. So now we just need to type it in. So 12.755, take away 4.895, and that's over 2.45. Press equals, we'll get our answer, and this one does come out as quite a horrible number. It's 3.208163.265. Now, on my actual calculator, it does actually keep recurring. It goes on for quite a while, but if you have the little button on your calculator that rounds it slightly, then I'm going to write that number down. So that is my lower bound for B. Now again, it doesn't tell me here to give my answer to a certain amount of decimal places. So I would leave it like that. Obviously that's quite a big number there, but I'm going to write it on the dotted line. Now typically on questions like this, not all questions, so my best advice is don't round numbers unless you're asked to. But on questions like this, where it doesn't say how to round your answer, quite common that on the mark scheme it says something along the lines of allow answers within this particular range. The range is normally quite small, so don't take any risks with that, but just so that you're not panicking about particular answers, sometimes there is a very small range. You're not going to get marked down if you miss a little decimal off the end or something like that in a question like this. But my best advice is always write down all the numbers that are on your calculator screen unless you are asked to round it. Okay, there we go. So that was looking at some bounds. Okay, so in this question we have an iteration, and it's an iteration that's in context. So it says the volume of the water in a tank n minutes after the emptying begins is V with this little n litres. The volume of the water in the tank n plus 1 minutes after the emptying begins, and then we have the formula. So it says to get the next amount, and that is going to be in minutes, so the next minute, we do k times the current amount plus 20, where k is a constant, so it doesn't change throughout. It says the tank starts with 1,200 litres of water at 9:15, and at 9:16, so 1 minute later, the volume of water in the tank is 1,040 litres. Look at the volume of water in the tank at 9:18. So for this here, we are given the starting amount and we're given the next amount for that first minute. So if we take this formula and we put the pieces in that we've been given, so 1,200 litres at the start and 1,040 litres in the next minute, then we have the answer at the start of that formula. 1,040 is equal to k, which is just something, times the current number, 1,200 plus 20. Now it's up to you, but this little bit here, k times 1,200, normally when we times a number by a letter, that would be written as 1,040 equals 1,200k plus 20. Now that little formula there, or this little equation now, is quite nice because we just need to take away this 20 from both sides, like we would with a nice two-step equation. We get 1,020 is equal to 1,200k, and then we would divide by the 1,200, as that's what's on our k there. We want to know the value of just 1k, not 1,200k. So 1020 on the calculator, divide by 1,200, and that is equal to 0.85. So 0.85 is equal to k. Now we know the value of that constant, we can actually rewrite our iteration formula. So it would now be v n plus 1 is equal to 0.85 multiplied by Vn, the current number, plus 20. So we now know the volume of water at 9:16, which is where we're at the moment. 9:16 is equal to 1,040 litres. And we want to know the volume of water in the tank at 9:18. So we'll follow our normal iteration process to get 9:17 next. So we'll do 9:17. So to get that, we do 0.85 multiplied by 1,040 and then add 20. We could type that in the calculator, so 0.85 times 1040 and then add 20, and that gets us 904. That's now our current solution. So for 9:18, to finish this off, we do 0.85 multiplied by the current number, 904, and then add 20. So just reusing that previous answer to work out each part or the next iteration. So times 904 and then add 20, and that gives me 788.4. And there we go, there's my final answer, 788.4, and that is the volume of water in the tank at 9:18. So there we go, we'll just write that in, 788.4 litres. So there we go, that was in real life or in context iteration question with a constant involved, but after finding that constant, we treat that in exactly the same way as we would with any other type of iteration question. Okay, so on to our next question, and we are looking at a trigonometric graph. Now this graph shows the sin graph between 0 and 360. It says using this graph, find estimates of all four solutions of sine x is equal to minus 0.8 for 0 to 720. Now this graph doesn't extend to 720, but we'll talk about that once we've found our first two solutions for where sine x is equal to minus 0.8. So minus 0.8, that is on the y-axis. So we're looking on the y-axis. This is minus 0.5, so 6, 7, 8, that there is minus 0.8. Now if we go along, and we'd want to use a ruler and a pencil here, you could do a dotted line or a straight line, completely up to you. But it crosses through the curve at two specific places, right here and right here. I'm going to read those as accurately as we can. Now if I go up to the x-axis. That one goes to there. And the second one is just here. And I want to read those two values. That's going to give me the two values of x that are equal to negative 0.8. So we need to have a look at the scale very carefully here. Because of the scale, it is a little bit strange. Not many scales like this. So we have these sort of every 5 lines we can kind of count. So it goes from 180 to 270. And there's 2 extra gaps or 3 jumps between there. So that goes up by 90. So each one goes up in 30s. So this would be 210 and this would be 240. That's just going to help us just to break this down so we can read it a bit easier. This one would be 300 and this here will be 330. So in between each sort of number that we've labelled, looking between 180 and 210, there are 5 squares. So 30 divided by 5 means each square goes up in 6s. So this one just here is 6 below 240. So that would be 234. And this one over here is 1 square above 300. So that would be 306. So they are our first 2 solutions. Now, although we can't see it, and although we don't even have enough space to sort of extend this graph, the curve just carries on and it keeps repeating this process that the curve has. It goes up over that 180, so between 180 degrees it curves up and down. Then the next 180 degrees it goes underneath. Then the next 180 degrees it goes up and over again. And the next 180 degrees, taking us to 720, goes underneath. So if we could carry this on, 360 degrees later, we would meet the curve twice again. So to get our other 2 solutions here, we would take the 234, which we already have, and the 306, and we are going to add 360 to both of those. So 234 plus 360, and also 306 plus 360. And that's going to give us our other 2 solutions. So we'll do that on the calculator. 234 plus 360 is 594. And 306 plus 360 is equal to 666. So there we go. There's our other solution. 594 and 666. So there we go. That is our 4 solutions between 0 and 720. Okay, for the next part of this question, we are looking at a graph transformation. So it says here's the graph of y equals f of x on the grid. Draw the graph of y equals f of, and we have x plus 1 in the brackets and plus 2 outside the brackets. So inside the brackets affects the x coordinates, it moves left and right. This particular one, when it's in the brackets, it does the opposite. So this particular transformation moves it 1 to the right. And this transformation at the end moves it 2 up. So in order to do that, we need to find some nice coordinates. There's one here, there's another one here, one there, and then this end point just here. And all we want to do is either move them all right and then all up, or each point we can go right by 1, up by 2, and just draw that in. So if I do the first one, right by 1 gets me to here, and then up by 2 would get me right up to the top, just here. So for the other points, I'm not going to draw them all in because it'll be a complete mess. I'm just going to sort of do it as I look at it. So right by 1, up by 2 gets me to here. Right by 1, up by 2 gets me to here. And the last one, right by 1, up by 2, gets me to there. So of course now we just want to sketch that in. Again, nice and neatly, ruler, pencil, nice neat drawing. If it's a curve, of course, we can redraw it as a curve, but this one had nice straight lines. So there we go. There is my graph transformation where it's gone right by 1 and up by 2. And there we go. There is a graph transformation. So on this question, we have a graphical inequality. We have 3 lines that we're going to have to draw here, and it wants us to shade the region that satisfies these inequalities. So for each one of these, I'm going to first replace the inequality with an equal sign, because these are the nice straight lines that I'm going to have to draw. And y equals, I'm going to rewrite this as negative 3x plus 6. So it fits that y equals mx plus c drawing, or however we'd write it like that. Just prefer that when I draw my lines personally. You don't have to though. These also have inequalities where the inequality symbol does not have the extra line underneath. So when we draw these lines, an inequality symbol like this will have a nice dashed line, and an inequality symbol like this will have a nice thick undashed line. So we are going to be using the dashed line when we draw these. So x equals 3 is probably the easiest one to draw, as that is just a nice straight line going through 3 on the x-axis. So I'm going to draw this in with my nice dotted line, making sure it's nice and clear. I'm going to extend it all the way to the end of the graph. Obviously, you can use a ruler and a pencil. I can't use a ruler with these dashed lines, sadly. But there we go. That's my first one. I'm going to tick that off just to make sure I know I've done it. The next one, we have half x minus 2. Now what you can do for these is you can draw yourself a little table of values. And you only need to use a few, because once you've plotted a few points, you can connect it all up with a ruler. So if you feel free to draw a table of values, I'm going to use the y-intercept plotting method. So I'm going to start on negative 2 for my first point, and it has a gradient of positive 1/2, which means for every 1 across to the right, I'm going to go half up. So if I go 1 across, half up, 1 across, half up, and I'm going to keep going, and you start to see the pattern, and there it is, and I can follow that pattern backwards as well. And once I've finished drawing my pattern in, I'm going to join that up again with a nice dotted line. If you want, as you draw these, you can also label the line. You can put a label on each one so you know which one it is. Completely up to you. You don't gain or lose marks for that. It can look nice when you label it. So that one's done. And then on to the last one, negative 3x plus 6, which means my y-intercept starts at 6. And it has a gradient of negative 3, which means as I go 1 across, I go 3 down, which gets me to here. 1 across, 3 down, gets me to there. 1 across, 3 down, 1 across, 3 down. Now that is quite a steep line, so that's a bit of an awkward one to draw, much easier if you have a ruler. So I'm going to do my best to connect this up using my dashed line. There we go, I think we're doing okay. Obviously much easier using a ruler and a pencil. And there we go. Awesome. So we have to label the region that satisfies these inequalities. Now a few things can help. We know that x has to be less than 3. That's that middle one here. X has to be less than 3. And that one there is going to help us to get rid of some of the regions that we don't want. If x has to be less than 3, it has to be on the left-hand side of that straight vertical x equals 3 line, which means it can't be this region. It means it can't be this region, and it means it can't be this one down here. So they're the regions that it can't be. It can be potentially any of the ones on the other side, and depending on how good you are at reading an inequality, then you might be able to use it to help you a little bit. But what I would suggest you do is you pick a coordinate in a region and we substitute it into those inequalities and see if it works. So try and pick a relatively nice number. There won't always be nice numbers. This region down the bottom here, for example, I could pick this coordinate here, which has an x coordinate of 1, which is nice, and a y coordinate of negative 3. Now if I substitute that into the inequalities, we'll know if it works or not. So for the coordinate 1 and negative 3, thankfully for this one I don't have to test that middle one, because yes, x is less than 3, but I will have to test the other two, and they're not the nicest of inequalities to test. So for the first one, y is less than a half x minus 2. Well, is negative 3, the y value, less than half of x, so 0.5 minus 2, so that's minus 3 is less than, and then 0.5 take away 2 is minus 1.5. There we go. And again, you can use a calculator for this. You don't have to do any of these sort of mentally. So yes, negative 3 is less than negative 1.5, so that works. And then I can sub it into the last inequality as well. So it's 6 take away 3 lots of x. So negative 3, it says, is less than, in fact, I think we need a little bit more space for that. So we have negative 3 is less than 6 take away 3 lots of x. So x is 1, so 6 take away 3. Negative 3 is less than 3. Yes, it is. So actually, by luck, because I didn't know that that was the region there, but by luck I've actually got that region straight away. So that region that we're looking for, let's have a look. It says by shading the region, and it says label it R. So for this one here, we don't need to do a huge amount of shading in it, just a little indication that that is the region that we are going to be shading there. We've got our working out sort of to back that up, and it says label it R. So I'm going to put a nice R in this region, and there we go. That is the region there that satisfies the inequalities. Now, of course, by chance, I happen to get that region in the first pick. But if it doesn't fit or work, or the mathsy word is satisfy the inequalities, then you would just have to pick another region. And there's not many to pick here. Maybe by the time you pick the second one, you're going to get it. But try and think a little bit logically. If the little shape in the middle, and you can see it kind of makes this little triangle on the inside, but you can see there was no coordinates within that. Now normally I'd actually pick that one first, but because there was no whole number coordinates, I just had a feeling it might not be that one. So just watch out very carefully. I would pick that one in the middle first normally if it had a nice coordinate inside it. But there we go, there is graphical inequalities. Okay, so with these questions where we have these two triangles that are put together, neither of these are right angled triangles either, it normally does give a big hint here that we're going to use using our further trigonometry. So we have the sine rule, the cosine rule, and the area of a triangle. So let's read the question, see if it mentions anything about area, calculate the length of QS, give your answer to 3 significant figures. So nothing to do with area, so we don't need to worry about that one. So we are going to be using the sine and cosine rule, potentially both, potentially just one, but let's figure it out as we go. So it says the length of QS, which is over here. So I'm going to put an X next to that one just to remember that that's the sort of target length that I'm looking for. Now as it stands on that triangle, it'd be a little strange if I could work it out straight away, because then the triangle attached to it would be completely pointless. You may as well have just given me that triangle down below. So I can't work it out straight away because X is opposite the 88, and there is no other pair of opposites to use the sine rule, and there is no other side lengths to use the cosine rule. However, this side that's attached, which is opposite the 41, would allow me to use the sine rule to get the value of x if I had that length RQ. So we're going to need to work out that length RQ. Let's call that y. So looking at this triangle on the top, can I figure out the length of y? Well, to get that, it's opposite the 27. However, I don't have any other pairs of opposites, so I can't use the sine rule. But I do have the two side lengths that make this angle, the 9.4 and the 11, which means I can use the cosine rule. So for y, that would be my value of a, and this would be my large A, and 9.4 and 11 will be b and c. Again, they can be written in either order. So y squared, the one that we've called y, is equal to, and the cosine rule is a squared equals b squared plus c squared, so 9.4 squared plus 11 squared minus 2bc, so times 9.4 times 11 times cos, and then the angle 27. You don't need to put a time sign there between 11 and cos 27, but as we put time signs between everything else, we may as well. So it's always worth writing the formula down. A squared equals b squared plus c squared minus 2bc cos A. Just to make sure as we move through the question, we're obviously not making any mistakes with our formula. Now, completely up to you at this stage. There are two ways, I think, of doing this next step. You can either type in everything there on the right and then square root your answer, or what I tend to do is I tend to just put a square root symbol and then type it all in. It does it all for me in one go. But that's completely up to you. I'm going to write y squared equals, because I know not everybody does that. So 9.4 squared plus 11 squared minus 2 times 9.4 times 11 cos 27. So we get y squared is equal to 25.0998508, and then I'm just going to press square root of my answer, and I get y is equal to 5.009975129. Now, we probably could round this number at this point to 5.01. It's so close to it, and it only wants my answer to 3 significant figures. But I'm going to leave the number on my calculator. I'm just going to leave it there completely now. And when I come to now look at this other length, I'm going to use the number in my calculator. So I'm going to put 5.01 here on the diagram, purely because I don't want to write all over the diagram. I know that that's now the number 5.01. So now I'm going to move on to this other triangle. Now we already said we can now use the sine rule because we have these pairs of opposites. So I want to label this up with my sine rule, and the sine rule for a side length is going to be a over sine big A is equal to b over sine big B. So I want to label x with my A, 88 will be my big A, and then the other side that we have, little b, and the angle here, big B. So I put all my pieces in place. We have x over sine 88 is equal to 5.01 over sine 41. Again, I've still got the whole number in my calculator. So to isolate the x, I'm going to times both sides by sine 88, and that will give me x is equal to 5.01 sine 88 all over sine 41. I can now just type this in my calculator, except when I type this number in, I'm going to use my answer button on the calculator because I want to get the full unrounded version in there. So I'm going to press my fraction button, answer sine 88 over sine 41. And I press equals, and I do get my final answer now. I get x is equal to 7.63181, and then a few more decimals, but of course it wanted my answer to 3 significant figures, which is after the 3 there anyway, so we get a final answer of 7.63. There we go. Let's think about the concept of this question. It was in centimetres, it was a side length, so that is 7.63 centimetres, and that is my final answer. So there we go, a big combination there of using the cosine rule and the sine rule, and that really important step there of knowing when to use the sine rule and when to use the cosine rule, and it's all related to whether you have those pairs of opposites. So 7.63 as my final answer, and there we go, that was the sine and the cosine rule. Okay, so this question here, it says, in a wildlife centre, there are 32 adult birds and 32 chicks. 19 of the adult birds are female, 12 of the chicks are female, 1 adult bird and 1 chick are going to be chosen. To make a pair, Liam thinks that there will be 2 males in more than 30% of the possible pairs. Is Liam correct? You must show how you get your answer. So when looking at this, we have some different options here. Now this is the product rule. So for this, for the total amount of pairs, we would look at how many adults and how many chicks there are, because 1 adult and 1 chick is going to be chosen. For the total amount of pairs, it would be 32 adults times 32 chicks. And 32 times 32 is 1024. So that is the total pairs. Now what this question is asking about is whether there will be 2 males or 2 females essentially, but it says Liam thinks there'll be 2 males in more than 30% of the pairs. Well, this information that's given to us is about females. So here in the adult birds, there are 32 adult birds and 19 are female. So when working out the total amount of females, we could have 19 in the first pick when we are picking the adult birds. And it says that there are 12 of the chicks that are female. So if when we picked a female, that would be multiplied by 12, and that calculation there would be the total number of pairs or possible pairs that would have 2 females. So if we work that out, 19 times 12, that would give us 228. So that's the total amount of pairs that would be 2 females. However, that isn't really necessarily going to help us here because we want to know the combination that will have two males. And there's obviously different combinations. We could have a female adult with a male chick, and we would have to sort of work them all out. So what might be easier for us here is to first work out how many males there are. So for this first one, to work out the amount of males, we do 32 minus 19. 32, take away 19, gives us 13 males. And here, for the chicks, 32, take away 12, gives us 20 males. Now, if we were to multiply these two together, that would straight away tell us the amount of pairs that have two males in. So we wouldn't have to start working out all of them here. So this particular one here that we've just worked out, 19 times 12, we'd need to do quite a lot of these different multiplications to get to our final answer. So this one here is female pairs. Okay, we'll keep the working out there because it's still something that we've worked out. But the nicer one, the quicker one that we could do is 20 times 13. So 20 times 13 gives us 260. And that's the male pairs. And now we can have a think about whether this is 30% of the possible pairs. It says Liam thinks there'll be two males in more than 30% of the possible pairs. Well, let's work out what 30% of the possible pairs are. So here, our total pairs is 1024. So if we work out 30% of that, so 30% of 1024, and different ways that you could work that out. I'm going to do 1024 times 0.3, which will work out 30%. You can work out 30% however you feel more comfortable doing so. That gives me 307.2. So 30% is 307.2, but our male pairs only comes out as 260. So is Liam correct? I would say no. Liam is not correct. If you wanted to give some more language alongside that, maybe you feel your working out isn't clear enough, or maybe your working out is a little bit scattered over the page. Obviously, I'd advise you to keep it nice and ordered. But here, I think my working out's nice and clear. But if you wanted to write alongside that, no, because there are 260 potential male pairs and 30% would be equal to 307, then you could absolutely do so. But there we go. That was the product rule for counting. Okay, so our next question is looking at completing the square. So it says, given that x squared minus 6x minus 1 equals, and then we have the completed square form, and it says for all values of x, find the values of a and the value of b. Now, completing the square is a nice topic. We halve this coefficient here and put that into our squared bracket. And this is our squared bracket just here. So we have x minus 3, and that's squared. Now all we have to do is think to ourselves, what would that be when we expand this bracket? Well, this would give us plus 9. Now we don't want plus 9 because in the question we had a minus 1. So we just need to think to ourselves, well, how do we make this squared bracket balance out? So it would in fact give us negative 1. Well, to get from 9 to negative 1, we have to subtract 10. And there we go, there's our values. So we've got to be really careful here though, because we might just say a is negative 3. But in this case, it's actually not, because up here, the negative is already there. So the a itself is just that number 3. The b itself is just that number 10. But watch out, because if those symbols had have been pluses, then yes, a would be negative 3 and b would be negative 10. So just be really, really careful here, particularly when those sorts of things are thrown in, that you are super careful with the symbols that are in front of a and b, because those negative symbols are already there. And if we said a was negative 3, well, minus 3 would actually make it plus 3 and it wouldn't match. So just be super, super careful when you have those things there with the symbols already in place for you. And there we go, that is completing the square. So in this question, we are looking at a circle theorem. Now we may have more than one circle theorem involved, so we want to read the question carefully and obviously be well versed in our circle theorems. But it says A, B, C and D are points on the circumference of a circle. A, B, E and B, C, E are straight lines. So we're not given a huge amount of information. It wants us to work out the size of angles C, D, E and give a reason for each stage of your working. So CDE is this angle just here, with D in the middle there. And we are looking at a few circle theorems here, potentially. Now it says A, B, C and D are points on the circumference of the centre of the circle. So straight away that stands out to me because this creates a cyclic quadrilateral. So if we have a cyclic quadrilateral, then those opposite angles are going to add up to 180. However, we don't actually have any of them. But we do have an angle at the centre here. We have an angle at the centre of 132, and that also makes an angle up here at the circumference. And we know angles at the circumference are half of the angle at the centre, or of course you can say that in reverse, but we need to do 132 divided by 2, which means this here is 66. Now I'm going to write my working out down next to that, 132 divided by 2, and that's equal to 66. Now of course it says that I need to show or give all my reasons for each stage of my working. So somewhere next to that I need to write down the rule, which is angles made at the circumference. There's lots of different ways that you can write this down. You don't have to write it down in the exact way that I am. But angles made at the circumference are half the angle made at the centre, or the angle at the centre. I'm going to say something like made via the same 2 points. The same 2 points on the circumference. That's a very long explanation. There are different ways of saying a lot of these. So if you know another way, that is fine. But there we go. I like that way of saying it because it doesn't sort of use sort of strange-ish language. But if you're very good at circle theorems and you're good at your reasons, of course, just write down the reason that you know. But that one there, angles made at the circumference, a half angle made at the centre via the same 2 points on the circumference. Okay, you can say it in different ways. You can use the word arc, you can use the word subtended instead of made. There's lots of different variations of the language, whatever you prefer. But that's what I'm going to write down for that one. So now I have that one, I can now actually look at this cyclic quadrilateral. So for the cyclic quadrilateral, I'm looking now at the angle which is opposite the 66, which is this one down here. So that 66 has now opened up that angle. This is going to allow me to work it out because the opposite angles add up to 180. So I can do 180, take away 66. Again, I'm just going to type all these on the calculator. I've got enough to think about without having to do the working out, so let's use the calculator. So that's 114. And for the reason there, opposite angles in a cyclic quadrilateral add up to 180 degrees. There we go. That's quite a nice one. Probably one of the nicest ones. There we go. Quadrilateral add to 180 degrees. And you don't have to label this around the diagram. You can obviously write some 3-point angle facts down below. BCD equals 114 because, and then write the reason. Again, it's completely up to you how you choose to do it. I'm just labeling it around the diagram because 1, it fits on the screen nicely, and 2, because it's absolutely fine to do that. So that is using my circle theorems. Again, that second one there, one of the nicest to write down, other than, I guess, where a tangent meets a radius is at 90. That's quite a nice one as well. But here, just watch out, because this is quite a common one in the sense that this little quadrilateral looks like they might be a cyclic quadrilateral, but that point is at the centre, not at the circumference. So watch out, there's no relationship in terms of the 180 between those two. So we do have a few angles now. Is that going to help us now get to that final answer? Notice how I haven't really focused about how to get the answer yet. All I've done is I've worked out what I know, what I can find using circle theorems. Now I'm kind of a little bit stuck in terms of there's no more circle theorems that I can really move around this shape trying to find. I mean, there's ways I could, but I'm probably overcomplicating it. So I'm just going to stop now and think about, can I now get to that angle? Now I can work out this here because it did say in the question that BCE was a straight line. So I know that those two add up to 180. So this one here will be 180 minus the 114. And again, just do that on the calculator, 180 minus 114. Of course, we already know that that's 66. It's on the other side of the cyclic quadrilateral there. So that one there is 66. Again, reason for that, angles on a straight line equal 180. There we go, nice reason. Line, I'm just going to put equals 180 degrees there. And now we can actually finish this question because outside of the circle, we have this large triangle, which goes all the way down to the 16 over here. And we have two angles within that triangle. So for this final angle here, angles in a triangle add up to 180. Take away the 66, add the 16, which are already in the triangle. So 180, take away 66, add 16, and that gives me 98 degrees. And again, reason for that, angles in a triangle you can write sum to or add up to. I'm just going to put add to 180 degrees. And there we go, there's my final answer, 98 degrees, just a little bit bigger than a right angle. And we have found lots of angles along the way. We've given loads of reasons along the way. Also, if in a circle theorem, there are multiple different ways of answering it, you do only have to write down the reasons for the route that you've taken. But for this one here, I think that was possibly one of the only reasonable ways of doing it. There are potentially other ways of moving around, but that was the most reasonable, definitely the most logical way of moving around that particular question. So there we go, the final answer there is 98, and we give all our reasons along the way. Okay, so our next question is looking at an indice problem. So for this one here, it says work out the exact value of x, give your answer in its simplest form, and you must show all your working. Just give us a bit of a hint there that it's not going to be a nice solution, as it says give it in its simplest form, and we have the exact value of x. So for this type of question here, we need to have a look at the numbers and see what type of problem we're actually dealing with. We know with indices, multiplying indices, we can add the powers, dividing indices, we can subtract the powers, all these sorts of different things, but that only applies if they have the same base number. Now here we have a 2, a 32, an 8 and a 4, but they are all powers of 2. So if you were to get on your calculator, just do 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, and sort of work your way through the powers, you'll see that all of these numbers appear as different powers of 2. Now spotting that is probably quite an important part of this topic, but we're going to write all of these numbers, or rewrite all these numbers, as powers of 2. So if we go about doing that, we have 2 to the power of x is equal to, on the top there, we have 32. 32 is 2 to the power of 5, multiplied by, in the bracket, we have the square root of 2 cubed, and that's all to the power of x. And that's all over. 4 is 2 squared. I do have to introduce a bracket here, because the 2 squared is to the power of x minus 1. So basically all I've done is I've swapped all those numbers for powers of 2. They all now have the same base number. So all of those laws of indices can now be applied. We do still have a few tricky little bits here. This bit here with the square root of 2 cubed is a bit of a tricky one, because we have to recognise that something as a square root is also a power of 1/2. So that is 2 cubed to the power of a half, and that's also to the power of x, which is why I'm not writing it all in one big thing, because any more brackets and that's going to look a little bit ridiculous. But we can multiply the powers here, and that would become 2 to the power of 3 over 2. So we could rewrite this. I'm going to leave it there for the moment and just see where we're at. But is there anything else that we might want to rewrite? Now we're going to have to rewrite the bottom as well, because we also have this 2 to the power of x minus 1, and we can times that power as well. So let's rewrite this all again. So 2 to the power of x equals, we have 2 to the power of 5 multiplied by, and I guess before we rewrite it, to save ourselves having to rewrite this again, which would be a bit of a pain, let's just work this bit out on the top, because now we have, again here, 2 to the power of 3 over 2, all to the power of x. and that is going to be equal to 2 to the power of 3x over 2. And there we go. So that's the bit that we now have on the top. Now just even that bit alone was relatively complicated, so let's get that all in, so just to avoid having to rewrite this fraction out over and over and over again. So there we go, that's the numerator tidied up for now at least. And the bottom, we're going to times those powers, so it's 2 to the power of 2 times x is 2x, 2 times 1 is 2, and it's minus, so minus 2. So we're almost in a position now, well, we are in a position where we can actually start to deal with this problem. It's still complicated, but we are in a position where we can start to deal with it. So now we have the same base numbers as well. We can add these powers on the numerator. So if we add them together, it's not going to look particularly pleasant, but on the numerator we will have 2 to the power of 5 add 3x over 2. On the denominator we have 2 to the power of 2x minus 2. We can now subtract the powers. Again, it's not going to look particularly nice, but we have 2 to the power of x, which will equal 2 to the power of 5 plus 3x over 2. Subtract 2x minus 2. And notice I've put that power in a bracket there. As we're going to be subtracting both pieces, it is going to change the sign of the negative 2. So I could tidy that up, but we are in a position now where we can see that this power of x has to equal to this huge power over here. That's quite a large power there. So now we're at this point, we can say that x must be equal to the other power of 2. We'll try and tidy it up as we go as well. So 5 plus 3x over 2 minus 2x, and then we'll have plus 2. Okay, so now we need to just tidy this up. We have some like terms that we can collect together. We've got the 5 and the plus 2. So x equals 7. And we have to tidy up or collect together this x pieces, or these x pieces. Now we can do that, but we are going to need them both to have a common denominator, as they are fractions. So we have the 3x over 2, or one of them's a fraction, and we're going to take away, and 2x, if we want to write that over 2, we would just double the top, so it would be 4x over 2. So there we go, that is my 2x, but written over 2. We can now join those up, so that gives us minus x over 2. And there we go, so we get 7, and we'll put that in over here, minus x over 2. And there we go, I'll just indicate there that that's where we're doing our working out. So I'm almost at a point where I can basically say what x is. I just need to get rid of this sort of fractional component, so we can times everything by 2, both sides. That'll get rid of that fraction. We have 2x equals 14 minus x. I can now add x to both sides, and we get 3x is equal to 14, and then I can divide by 3, and we get x is equal to 14 over 3. And there we go, and there is our final answer, x is equal to 14 over 3. So there we go, not the most pleasant of questions, the powers there. Obviously, initially you had to spot all of those base numbers being written as a 2. There was lots of little steps along the way that could have thrown you, particularly this step here where we have the minus 2x and the minus 2. So we need to be very, very careful there with the symbol in front of the 2, the negative, changing to the positive, and just being super careful along the way. Now, there were different ways that you could simplify along the way there. If you did it in a slightly different way, that's absolutely fine, as long as we get to that final answer of 14 over 3. And there we go, there was some quite tricky indice question. So in this question, we have some quadratic inequalities. There are two types of quadratic inequalities here. We have the difference of two squares on the left, and we have this harder, higher coefficient of x squared one on the right. So I'd start with the slightly easier one, the difference of two squares one. This one's nice and easy for us to factorise. We get x plus 7 and x minus 7, and that gives us two solutions. We have x is equal to negative 7 and x is equal to positive 7. Now for an inequality, of course, the best way is to draw a graph for this, just to envisage or imagine what it looks like. We have a positive and a negative solution, -7 and +7, and we're looking at greater than 0, which is above the x-axis. So we have two inequalities for this one. We have x is always going to be less than -7 over here, and x is always going to be bigger than or greater than 7 on the right there. So that's our first one done. We now need to move on to our right one. Now for this one, we are going to have a 5x and an x. And of course, don't forget, if you are struggling to factorise, you can always use the quadratic formula, but it does look like this one is going to factorise. Now it says here 72 at the end, so we want to write down the factor pairs. We could have 1 and 72, 2 and 36, 3 goes in 24 times, 4, again you can use your calculator for this, but 4 goes in 18 times, 6 goes in 12 times, and 8 goes in 9 times. So they are the factor pairs of 72. Now one of these numbers is going to get times by 5, and we're trying to make 31. And just as I wrote it down, it stood out to me the 8 and the 9 is going to work, because 8 times 5 is 40, and then you can take away 9 from that to get 31. So we want to make -31, so we want the 8 over here to make 40, we want to make -40, add 9. And there we go, there's our two numbers that go into our factorised brackets there. So we get two solutions, x is equal to 8, and x is equal to -9 over 5. If we type that into a calculator, that's -0.8. You can write it as x is equal to -1.8 if you would prefer. And again, if we draw a graph for this, then we have a negative and a positive solution. We have -1.8 and +8. Again, we are looking at numbers above 0 or greater than 0. So it's these two parts again, which leaves us with two inequalities. X is always going to be less than -1.8, and x is always going to be greater than +8. So just say here, find algebraically the set of values for x, which, and then we have our 2. Now I could draw both of these curves as a sketch on the same x-axis. It wouldn't be the nicest to look at, and I probably won't be very good at drawing a sketch of it, but essentially we are trying to find the values that fit in both. So if we just look at the left point to start with, on the second inequality, we found that x has to be less than -1.8. However, because of the first inequality that said x is going to have to be less than -7, well, the numbers between -1.8 and -7 will only satisfy this inequality on the right. It won't satisfy both. So because of that, x is got to be less than -7 works for both of them. So that works for both. So that's one of our solutions. We take the same approach with then the right part of the curve. So we have the x has got to be greater than 8 on our right one, and x has got to be greater than 7 on our left one. Now again, numbers between 7 and 8 there aren't going to work because it's not going to fit into our right inequality where numbers have to be bigger than 8. So 7.5, for example, is not bigger than 8. Works for the left, doesn't work for the right. However, on this right one, if we have x is greater than 8, that works for both of the inequalities. Any number bigger than 8 is also bigger than 7. So they are our two inequalities. X has to be less than -7, which we've got from our left one, and x has to be greater than 8, which we've taken from our right one. So there we go. That was using some quadratic inequalities and actually finding almost a set of values in terms of these two solutions that satisfy both of them. So there we go. That would be our solution. X has got to be less than -7, and our second solution, x has got to be greater than 8. And there we go, there is our quadratic inequality, and I would definitely emphasise the importance of drawing those curves there just to visualise that a little easier. Okay, on to our next question. Okay, so on to this question, we have prove algebraically that the straight line with equation x minus 2y is equal to 10 is a tangent to the circle with equation x squared plus y squared equals 20. Now, not forgetting what a tangent is, if we have a tangent, it means that we have a circle with a straight line connected to that meets at just one point. So if we're going to think about this as a tangent, then there are two methods that we could potentially think about using. We could potentially have a think about finding the negative reciprocal gradient and using our normal tangent method, or we could think about actually solving this as it's asked us to do algebraically by using simultaneous equations. Now, when you have a tangent to a circle, it means when solving them simultaneously, we should only get one solution, because normally, and in the vast majority of quadratic simultaneous equations, you will normally get two solutions. But if it's a tangent, we should only get one value of x and one value of y, as they only cross over or touch at one coordinate. So let's take the approach of a simultaneous equation, which means our first equation here needs to be x equals or y equals. So if we add 2y to the other side, I'll slot it in before the 10, we get x is equal to 2y plus 10. We can now substitute that into our second equation in place of the x here. X will equal 2y plus 10, and we'll write that all out. So we get 2y plus 10 squared plus y squared is equal to 20. Of course, depending on how quick you are at expanding a double bracket, I'm just going to do this to the side just to show you all the process, that little bit of method there of expanding the double bracket. So that gives us 4y squared plus 20y and another 20y, up to you whether you write them both out. I'm just going to write that in one jump, so plus 40y plus 100. So that's what's going to go in place of my bracket there, and we also have this extra y squared. So I like to reduce as many steps as possible as I'm going through, so I'm going to write 5y squared plus 40y plus 100 equals 20. So I've tried to write that y squared joined in straight away, because I do notice sometimes we start to write out this big long line, we forget that that y squared actually exists there. So just add it in straight away, make sure we don't forget about that. I want this to equal 0 so that I can factorise and solve it. So minus 20, that gives us 5y squared plus 40y plus 80 equals 0. And now I want to factorise and solve this. Of course, we have a calculator, so we can use the quadratic formula, or I could just divide everything by 5 and hope that this is nice and easy to factorise. So that gives me 1y squared plus 8y plus 16 equals 0. And that's going to be relatively nice to factorise. 16 is only either 1 and 16, 2 and 8, or 4 and 4. And to make 8 in the middle, that's going to have to be 4 and 4. So it'd be y plus 4 and y plus 4. That equals 0. That gives me one solution. Y is equal to negative 4. I'm not going to write it twice. We get the same solution for that second bracket. Now normally, of course, with a quadratic simultaneous equation, we would substitute that back into the x equals formula. So if x is equal to 2y plus 10, well, when y is equal to negative 4, we get x is equal to negative 8 plus 10, x is equal to positive 2. So in terms of this, we get one coordinate, which would be 2 and negative 4, meaning that these graphs, this straight line and this circle, only have one point of intersection, which means that that line is a tangent. Now, typically with a question like this, we just need to ask ourselves the question, is it enough to just write a coordinate there? So I would probably, with something like this, and typically with any question that says prove, particularly algebraically, we want our answer to make a lot of sense. Here, does just writing a coordinate make sense? Well, I would probably put here we only have, or only one point of intersection, and therefore it is a tangent. Therefore, it must be a tangent. And there we go. That there adds just that extra level of proof that shows that you know what you're talking about. So there we go, only one point of intersection, therefore it must be a tangent, and we used quadratic simultaneous equations in order to figure that out. Okay, there we go. So that is the end of the paper. Hopefully that you enjoyed that paper. Lots to think about in there, lots of links in the description for all of these different types of topics that have been involved within this paper. But as always, good luck leading up to your Paper 2 exam, and I will see you next time for our next video and our next paper.